Hi, everyone. Welcome to our webinar session. We're excited you were able to join us. We're going to give people just another 30 seconds or so to hop in, and we will get things kicked off. All right, let's go ahead and get started. Once again, thanks everyone for joining us. We're happy you have decided to spend some time with us this morning or afternoon. Wanted to start off just with some brief intros and some housekeeping items. First off, wanted to introduce our presenter today. This is Sander Breenan. He is a customer success manager based out of our EMEA region. So we're happy to have him with us today. In terms of housekeeping items, if any questions come up throughout the presentation, feel free to put those in the Q&A portion of your Zoom window. We'll be able to get those answered either by typing them back to you through the Q&A, or Sander will have some time at the end to answer a few questions as well. Last thing, this webinar is being recorded, so we will be sending out a recording to you all here in the next day or two. And with that, I will turn the time over to Sander.
Thank you, Taylor. Thanks all for joining in this webinar on continuous delivery and GitOps. Let's get immediately started with it. So let's get started with a story I want to tell you. One day at my previous company, I'm working for Gitlab now for almost a year. And in my previous company, I had a customer that called in with a problem on production. And their production system didn't come up after they ran an upgrade based on a runbook we created for them. Yeah, they panicked, of course. So at that time, when we contacted this organization, they were in the process of restoring this production instance. They were restoring a production backup in their test instance and then trying to restore this, to promote this test instance to a production instance. So in a way, they try to have an existing instance and then promote that to a new production and then clean out the other one. Apparently, we investigated this problem and it turned out that they followed the runbook but forgot one step in that runbook. And when we applied that step, everything was fine. Now, the lessons learned in this story is that continuous delivery is very important, because if this organization had automated this runbook, then they couldn't forget this one single step, and then this upgrade wouldn't have failed. So one of the biggest challenges of organizations today is therefore to deliver software in a safe and reliable way. That's what I wanted to start with. This is also recognized by the Accelerate State of DevOps report. And they said in 2019 that delivering software quickly, reliably, and safely is at the heart of organizational performance. This is telling us that for an organization to distinguish itself from other organizations and to stay ahead of the competition, it is key to improve the speed and reliability of delivering software to production. There is hardly any process in your organization not relying on software. So think about it. Can you imagine any process, any service in your organization that is not relying on software? Now, I don't, and therefore software delivery is one of the key things to distinguish yourself from other organizations. But many organizations still struggle with this. And this is, of course, a comic. This is not real, but it does illustrate a little bit of what we do often see in organizations. A CI/CD pipeline that is hardly automated and heavily relying on runbooks, manual procedures, and last-minute fixes is what this comic is describing. And with manual procedures and runbooks, it's extremely difficult to keep track of all the commands you're executing in order to get a running system. And it's not only the commands that you enter beforehand to get to a system and that you then need to put in the runbook, but it's also to keep track of where you are at the runbook during a production deployment. That's also the reason why in my previous example, the production upgrade failed. Now, we didn't end up in a 50-person conference call in the end, but we have to apply manual changes in order to bring production back to a working state. With continuous delivery and GitOps, you want to avoid exactly these problems and start deploying with the confidence that it always succeeds. To start delivering software quickly, reliably, and safely, you need to have a few prerequisites in order. So to deliver software reliably, you need to have all the steps in the deployment process automated so that they can be repeated. Hence the runbook that we just discussed. To deliver software safely, you need to add quality and security checks in the delivery process. And to deliver software quickly, the deployment needs to start as soon as possible after security checks have passed, preferably automatically. And that is best managed via a deployment pipeline. So how does a deployment pipeline then look like? Now, in GitLab, you have a pipeline like this, for example. You see that it all starts with development making changes to an application, and that application is later deployed through a CD pipeline. This is where development and operations are connected together. To truly deliver or deploy an application immediately after security checks have passed, you need to connect the deployment pipeline with the development pipeline. That's what you see in this image. This is where DevOps comes into play, of course. So DevOps is a concatenation of development and operations, as you probably all know. And development teams are not longer only responsible for the software change, but also need to know something about the deployment and how to deploy that change into production. In order to do that safely and securely, you need, of course, quality and security built into your pipeline. But you also need a secure way of this pipeline accessing a production system. Operations teams have to therefore work closely with development to develop a pipeline that is able to deploy changes as soon as security checks have passed in a secure and reliable way. This is where GitOps comes into play. So GitOps also brings this DevOps practice to the infrastructure teams. Now, what is GitOps? Git is, again, a concatenation of Git that we all know as a source code management system, also the basis for GitLab, and operations. And GitOps is, in fact, push-based, or Git push-based operations. Git triggered workflows, so to say. What it requires, therefore, is that you see your infrastructure as a code base that requires testing, that requires quality assurance and security checks. When you look at your infrastructure as a code base, then it makes sense to apply the same CI/CD pipeline that you would use in development also to your infrastructure code. Let's illustrate that with another example. So in another organization I work with, they heavily scripted their deployment process using Ansible. So the only thing that they had to do was simply start an Ansible playbook, and a production update was running. So they automated their runbook, so to say. Part of their procedure was to test the update first by running the playbook on a test environment. Due to some restrictions, they had to do that from their local machine, and they equipped their local machines with all the required tools to execute these playbooks and access the systems that they needed to update. What happens every now and then is that people make changes in the playbook configuration on their local machine and forget to commit those or push those to the remote Git repository. So when there was a production deployment scheduled and they run the playbook, these tiny changes in the playbook haven't been committed, and therefore production upgrade fails with errors. That could have been prevented if you would have used a central CI/CD pipeline on your infrastructure code and have that run the deployment instead. So deploying infrastructure in a reliable way not only requires to describe the infrastructure in code, but it also requires a centrally managed system to deploy it. Now, an industry standard is not only Ansible, but also Terraform, and GitLab currently supports Terraform deployments. It allows infrastructure teams to manage Terraform state centrally in GitLab. I'll show that in the demo later. To deploy in a safe way, you need to add security checks as well. Many people already are using the SAST and DAST scanners on their applications, but we now also have SAST scanners on infrastructure as code, so on Terraform or Ansible scripts. I'll demo that later too. And now we want to deploy quickly as well. Now, with the GitLab Terraform integration, you can build a GitLab Terraform pipeline that automatically runs after you merged a merge request, and it will deploy your infrastructure automatically into one of the big cloud environments. This way, you avoid breaking your deployment with local changes, as I illustrated in the example. Good. So now we have a development team that is building an application. We have an infrastructure team that is responsible for the infrastructure where the application has to run on. The infrastructure team typically uses Terraform to deploy to any of the large cloud environments, Azure, Google, or Amazon. And they typically build then a Kubernetes environment. That's also what I use in the demo, a Kubernetes engine on either of these platforms where applications can land. Application development teams can then provide Helm charts or Kubernetes manifest files. Helm charts is in fact a sort of a configuration wrapper around these Kubernetes manifests. And they use those to deploy the applications on that infrastructure. As you can see, these applications use pods, and a pod is sort of a small service within the application that delivers a certain functionality, and it has different sizes. So there can be per application different resource demands on your cluster infrastructure. Therefore, close collaboration between infrastructure teams and app development teams to make sure that this infrastructure is capable of hosting your application needs. So let's look at a more detailed workflow now. Here we have a cloud operator that is responsible for the cloud environment, the deployment target in this case, and we have an app development team that's building an application. The deployment target, let's assume that that's a Kubernetes cluster running in one of the big cloud environments. The current state of that Kubernetes cluster is already stored in GitLab, and the cloud operator is responsible for making sure that the production environment is always up and that the cluster is capable to accommodate changes in the application being deployed. So we start with the app developer making a change in the app code repository. After pushing these changes to the central Git, you create a merge request. In that merge request, you can also include the cloud operator to review the changes made and make sure that the deployment target is capable of running this application. And if a change is needed, the cloud operator can also make a change in his infrastructure as code repository. Through a Terraform pipeline, and the infrastructure change will pass security scanning. When security scanning is successful, it will go through this Terraform pipeline to be deployed on the deployment target. You can optionally place a policy manager in between. That's from HashiCorp, like Terraform is also from HashiCorp, and that's an extra sort of device in between your pipeline to secure your environment. So in the Sentinel Policy Manager, you can define per infrastructure, per namespace or whatever, who is allowed to deploy where. This is not part of the demo, but it's optionally available and integrated. Once that's deployed, then the merge request that the app development team has created can also be merged so that the test and deploy pipeline, so the CI pipeline, can run and check the application. And after that, security scanning can kick in to check if the application is safe and secure to deploy. With that, we can use a GitOps architecture to detect changes in the application and then automatically deploy that through the Gitlab Agent configuration into the deployment target. Of course, with every deployment, there are definitely secrets like passwords, keys, certificates, etc. that needs to be deployed together with your application or with your infrastructure. We can integrate with HashiCorp Vault and store secrets in this Vault instance to use it not only in the deployment environment, in the deployment target, but also within your CI pipeline. This is also not part of the demo, but it's definitely nice to have and to integrate with it. So that's in a nutshell what I wanted to discuss on continuous delivery and GitOps. Any questions you can put in the Q&A section that's available within Zoom, and we will answer those at the end, either vocally or someone will answer them on the in written. Feel free to add any questions to the Q&A session already. But let me explain a little bit about the demo, how the demo environment looks like. I have created 4 projects for the demo, and that is to split the specific jobs that I want to show. So we have, again, an app developer and the cloud operator. So I wanted to sort of replay the workflow that we just saw. The app developer is going to change something in the Hello World app. And yeah, let's assume that that change requires also a change in the Google Cloud Kubernetes environment. So the cloud operator is going to make a change in that infrastructure repository that's deployed to the deployment target, whereas the Hello World app will deliver a Docker image, and then that Docker image is sort of promoted to production through this world greetings environment that will generate Kubernetes manifest files, and through a GitOps process that watches these manifest files, it will detect the changes and deploy those changes in the cloud environment. And then we have created the circle. Cool. I have to set the focus right. So let's dive into the demo. I start with the Hello World app. So this is the application that an app developer is developing on. And this guy's, it's simple micro web service that's going to give you a nice Hello World line. And I always change the background here to make something changing that's really visible. Let's open a web IDE and start with making this change. Of course, such a change isn't going to require any changes in the infrastructure, but nonetheless, we'll do as if that's important. So let's take my favorite color. That will be the new background. Change to orange. And then I create a new, it's a bit difficult to say with this dark theme, but I'll create a new branch here. And then I commit. So now I created a branch and that branch is then automatically created into a merge request. Now let's assume that we want to include operations here. Cool. For the rest, I can simply go forward with creating the merge request. So now we have the merge request open. I have included operations in this, so I can later on check this box to mark that operations is finished. And I have a running pipeline here. This pipeline is now doing a version check, but then it's building the Docker image and running a few tests, container scanning test, secret detection test, and a SAS test. And after that, it's deploying a review app automatically as part of the merge request. So the canonical build is already finished. So that means I already have the orange app here, and that's now 3 tags that contain the new version with the orange background. In the merge request, I said that we needed something changed by operations. So let's go into the operations project. The operations project is the only project that's running on a separate environment, which is self-managed. All the other projects are running on gitlab.com on our SaaS platform. But for the demo environment, we decided to use a separate self-managed environment, which is in fact the same thing, only self-managed. Here you see the Terraform files that will create a Google Kubernetes environment and Kubernetes cluster. Here you see that how it's working. This is simply a Terraform file that can be deployed through the Terraform integration. And in this one, I also include a GitLab Agent immediately. So I immediately deploy a GitLab Agent through the Terraform Kubernetes integration. And this GitLab Agent is also automatically reporting back to the cluster management project in our cloud environment. And that's then connecting the Kubernetes agent to the Kubernetes cluster. Now, I'm not going to make an infrastructure change. I wanted to make it easy for myself, so I'm going to change the version of the agent that's running in there. This is also much quicker than making a change, for example, adding a node or something. But also that would be possible. I'm going to commit to main here directly, also for demo purposes, because that way I skip the merge request pipeline and immediately go to the production pipeline. Normally, I would always make a merge request first and then test and validate, and then you go into a production merge. That's the idea of GitOps, is that you start your production pipeline through a git push and typically a merge request where you secure your main branch, where you add secure variables so that only certain people can see them, and the production environment is protected. This has triggered a pipeline, as you can see. So this pipeline is now running. And as you can see, it's also including a SAS test, a static analysis test on the Terraform files. It will check Terraform if the syntax is correct, if there's anything in the code quality context done against certain best practices, checking for any secrets or any other things that you could have done wrong in your Terraform code. Then it runs in the validate and plan, it runs a Terraform validate to check if the state file is still valid against what the changes that are planned on the cluster environment, and then the deployment is in this case manual. I'm sorry. So the Terraform state is stored here. You can see that it's the latest pipeline is passed. It's updated 7 hours ago. And here you can, for example, lock the state for only access of like GitLab. You can copy the Terraform init command or even download the state file. And you can even remove it. This is more like for troubleshooting. If you really are in trouble, your state isn't in sync with the cloud environment anymore, and it's impossible to get it in sync again, then what you can do is delete the state files and make Terraform create new state files for you. So that's like the last straw if you really are in trouble. You can also configure Terraform through CI/CD variables. CI/CD variables are very important, for example, to mask secrets like this API token, or to protect certain, here this agent token, for example, is also masked, or to protect certain variables for a certain environment. Or for if you protect the variable, it's only running on protected branches. So if you protect your branches well, then this variable is running only on that branch. And the variables that are prefixed with tf_var, these variables are then used within the Terraform files, and they are replaced automatically. So this GCP region, that's the variable how you see it in a Terraform file. And it's defined here with a prefix, and then GitLab will automatically replace it in the Terraform file as well. So that's a nice way to use your Terraform variables in GitLab CI/CD variables. Cool. Then the pipeline should be ready. Yes, so I can now deploy it to production. That should be fairly quick because I have a small change. And once that's done, then you will see in the Google Cloud that there is a new workload for the GitLab agent. So here's the GitLab agent. It's running at the moment already. And it's still on version 15.2.0. But when the deployment has finished, then you should see that the Google Cloud environment is going to terminate that pod and restart it with a new version. And that should then be 15.4.0 in this case. So that's the job. Now, if I go to workloads and the agent again, then you should see now that it's deploying 15.4.0, and apparently it's already running. So that was a very quick one. Yeah. No. So that's for the infrastructure. If you go back to the Hello World app, then this pipeline is now through, and it also deployed a review app, as I mentioned. So if I go to environments here, you can see that I have now a review app. I have even more review apps, but I deployed an orange one. So this one is now orange. Whereas if I go to the production environment, which is deployed through the environment project, and I go to production, then this production is still very bright blue. And the idea is now to go forward and merge the merge requests so that these production and also this staging environment will turn into orange. I'm going to go and merge the merge request now. This will now first stop the review app here in the existing pipeline, and I also created a new pipeline on the main branch at the moment. That's starting again with the version check, the build of the Docker image, testing, and then you see rather than creating a staging a review app, it deploys a staging environment, and then we go into a production environment. So this pipeline looks a little bit different than the merge request pipeline. This canonical build will start building the build on the main line, and then also add that to the container registry. So the container registry should then get a new version based on the version check. And this, I think, is the old one. So once that's finished, then we can see that. In the meantime, I'm going to show you what's happening afterwards. So once this pipeline is finished, I can promote that to production. And what's then happening is that this is going to the world greetings env. The world greetings env is the project that will build the Kubernetes manifests. So here are these manifests stored for production and for staging. Now, at the moment, the production manifest is still on version 1.09 for the Hello World app. So once I've promoted and run the correct pipelines, you will see that this is then upgraded to a new version label. And once that's done, then GitOps is picking this up automatically. So that's the idea of this demo. So let's show you that. I already showed you that in the Google cluster environment, Kubernetes environment, I automatically deployed a GitLab agent. And this GitLab agent is configured so that it automatically, once it's started, will call back to this cluster management project in gitlab.com. And you can see here that this GitLab agent has registered a Google Kubernetes cluster here. That's last contact was 4 minutes ago. It's now, as I recently deployed, 15.4.0, and it's configured in this way. So to deploy or not to connect a Kubernetes agent to GitLab, you need to create a config file first, and then add the Kubernetes agent to the project, and also have a registration token on the Kubernetes agent to connect back. Here you can see GitOps working, and I have configured on this agent a GitOps project, and this is manifest project that's looking at the world greetings env project. It's detecting changes on the manifest files, so the manifest directory and then all the YAML files within it. So if there's any change in the world greetings env in that manifest directory, then this Kubernetes agent is automatically picking this up. In this manifest directory, in that project, you have both production and staging manifest. I can imagine that to secure and separate production and staging, you would want to have a separate agent for your production environment and a separate agent for your staging environment, and also separate GitOps configurations. So let's go back to the pipeline. That should now be finished. And it's blocked now. So what I can do now manually is go and promote the image to the latest version. What this will do, it will tag the image in the container registry so that it has a latest pod environment that is then linked to the latest version. If I go to the container registry, then this should have a 1.0.10. This is published 4 minutes ago, and it should have a latest pod that is also published 4 minutes ago. And if you look at the digest, then it starts with CCE, and this one starts with CCE2, so it's the same one. So latest spot is now pointing to 1010. Now, once that's done, now I've promoted this to production. So yeah, I would typically also release this. I create a release. This is release 1010. And I can add a tag message here. I can set a release title, even add some release notes. Link to a runbook, for example, if you want that, or any other release assets. But what is most important is that this will sort of fix your release and wraps up the source code for this release and assigns that to this release version. So the release version is tagged in the repository. This also triggers a pipeline, as you can see here. So we now have not only the commit that is making this release tagged with the version, but also we have the source code related to that commit, how it was on that version packaged within the release, and therefore freezed in time. Cool. Now, I already discussed a little bit how that then happens. So if I go back to the world greetings env, this has to be changed. We want to update the manifest so that it reflects the changes. So what I do is I go to the pipelines and I run the pipeline here. This can, of course, be automated or scheduled or whatever. There's different ways on how you can automatically start this pipeline. But in order for me to tell things and to show you how things work, I need to do things manually so that the pipelines are not overtaking my story. So at the moment, we still have this blue backgrounds on both production and staging. And while the pipeline is running here, it's triggering a deployment pipeline. So what it's done, it's checked the latest spot label in the container from the Hello World app. Once it's detected a new version, it will trigger a child pipeline. This child pipeline will then start constructing the production and staging manifest, and it is then updating first staging, and then when that's successful, it will do the same thing on production. This takes a bit, but if we go to the repository, so this has created a new commit on the version 1010 in the main line to reflect the changes. So if I look at the staging manifest now, then you see here that is now on version 1010 that we just released. And this pipeline, when it's finished, then the GitOps will kick in. That takes a few minutes before it is picked up by the agent. You should see here now in Google Cloud that the agent is deployed, and it has now version 1010, whereas the production is still on version 109. If I go back here, then on the environment, you should also now see the staging environment being orange, whereas the production environment is still blue. So my final step in this demo is to finish the pipeline here. And do this for production as well. This will take a little bit, a couple of minutes. But then also the production environment will turn into an orange background. As I said, I have done this all with manual steps now, so I can show you in between that the environments are still different. And once finished, then the environments are changed. But in a real life environment, I would definitely make sure that this is automated. Let's see in the workload if It already has changed. It's about to change. So you see here now it's already on version 1010, and we are now in the middle of terminating the old pod and starting the new one. This does mean that if I go to the production environment here now, it should be orange. Yes. It's always nice to see that a demo really works and doesn't give errors. Cool. Now, of course, every one of you also wants to do this and wants to see how that works. Now, I have used publicly available templates most of the time. So the hello world and the world greetings ends are part of our guided explorations to test out Kubernetes Agent and GitOps. You can find those there. Cluster management is in fact an existing project template in GitLab. And the infrastructure is, in this case, loosely based on our infra standards initiative. I took a slightly different one, but it's the same thing and it will definitely work the same way. Whereas I've added this agent configuration to it so that you immediately have an agent available in your cluster instead of deploying that afterwards. A good resource as well to get started is this blog post, The Ultimate Guide to GitOps with GitLab. This blog post is in fact a blog post series of 8 or 9, I'm not sure. And so you can follow that step by step to get started with GitOps and continuous delivery in GitLab. We'll make sure that you also get these URLs later on after this webinar. And with that, I would like to thank you all. And I know that Taylor is about to launch a poll too. And after that, we can take some questions. So thank you all for listening in and bearing with me.
Thank you, Sander. That was great. Yes, I just launched that poll. So if you all want to take just a brief moment to fill out those 2 questions, we'd love to receive the feedback. And yeah, Sander, we did have some questions come through, so I'll go ahead and ask those to you, and you can go through those. So the first question here, in the development project, the review app is deployed as part of the pipeline, whereas production and staging are deployed in the ENV project. Is the review app also deployed via the GitOps configuration?
It isn't. No, and this demo consists of, in fact, 2 ways of deploying something into a Kubernetes environment. So the GitOps is detecting changes automatically on Kubernetes manifests that you will store somewhere. And in this case, I took a separate project for that, but you can also combine them. Whereas the review app and also the staging app, although I didn't show that on purpose, they are deployed automatically through our auto DevOps. So we have our auto DevOps template that you can use, and that will give you a very quick release pipeline with only including 1 template. And this template automatically deploys a staging and a production environment for you, which will work on a Kubernetes context that's pointing to the GitLab agent in the cluster management project. So I've pointed the Hello World app to that cluster management project, and that's where the agent is living, and therefore this review app job has access to this Kubernetes context and can deploy on Kubernetes. I can quickly show you that it's in fact a different namespace if I'm in the right one. So if I go into workloads, you see here different namespaces. So I've been deploying production and staging on this world greetings end namespace, whereas there's also a production and the staging in the GitLab managed namespace, and that's the auto DevOps pipeline kicking in. So that's that.
Great. Next question. In the detailed workflow, you have a separate cloud operations team, but with DevOps, isn't it then the idea to have one team with both developers and operations?
Yes and no. So DevOps is, of course, the concatenation of development and operations. And it's often also seen as simply adding operations into a development team. But if you read the DevOps handbook, that's definitely not the only way to do DevOps. And I certainly would recommend, if you want to apply DevOps, is to not only include people that are more into operations in your dev team, but also have like separate cloud operations teams that really take responsibility for your cloud environment, because managing an environment, whether it's in the cloud or in local hardware, it requires a lot of different skills and also continuously awareness. So you have to continuously monitoring it, for example. And of course, you can put a lot of that into the hands of the development teams if it's based on the applications, or the application monitoring. But the infrastructure monitoring, you would definitely want to have a separate cloud operations team for that.
Great, thank you. Next one here. We already have our Terraform files in GitLab. How can we start using GitOps? Yes.
So as you saw in the demo, is that the GitOps configuration with the agent is monitoring the manifest, the Kubernetes manifest. So it's in fact they're monitoring the application code. GitOps in the basis is in fact push-based operation. So you push a change into a Git repository, a centrally managed Git repository, and based on the merge request trigger, it will trigger a pipeline and then deploy the changes. So if you already have Terraform available and in GitLab, then what you can do is you can start building this pipeline, and the resource I just showed you with the Google Cloud Env project gives you examples on how to do that. So you create a pipeline that will run the Terraform validate and Terraform apply inside of your pipeline. And once you do that, then your Git push, your merge request will automatically trigger a pipeline to deploy your changes into production. And then that's in fact what GitOps is doing.
Great.
Does that answer your question?
I think so. All right, one last question here. Do we have to create 4 separate projects for this, or can this also be combined in one single project?
You can definitely combine things. For this to work now at the moment, it's still required that all the projects are in the public space, so that projects can really see each other. With separation of duties in mind, I have really separated all the different, how you say it, the different jobs, so to say, different functions in different projects. Also, it makes it a bit easier to see where we are in the process. But you can definitely combine a few things. For example, add the manifests into the application project, for example, or the cluster management stuff into the cloud environment project. That's definitely possible, yeah. You can even do everything in one project if you want to.
Great, thank you. Those are all the questions I saw. So we can go ahead and wrap up at this point. I wanted to thank everyone again for joining us today, and thank you, Sander, for that presentation. Keep your eyes peeled for additional sessions like this in the future. And with that, we'll say goodbye for today. Thanks, everyone.
Thank you. Goodbye.